drawbacks. Price points. This is key for the Indian market, right? A lot of the sensors that are developed right now that you'll see all out here, they can be ranging from $7 to $700, depending on what technology is used. Data throughput. Like we said, Alexa requires a fast Wi-Fi connection because you're sending a lot of data through that system. A Wi-Fi camera requires a lot of data, but a little temperature sensor or a smart meter may not require as much data as well. Security, now this is a big one. Security is huge because you don't want people hacking into your system. You don't want people, just like the speaker mentioned before and the panelist, to look at what you're doing through your Wi-Fi camera, or where people were able to hack Bluetooth locks. Well, you know, if you know just a little bit about Android and you know how to load the Android ADK, well, guess what? There's a Chinese app that's available that's used for locking Bluetooth locks. And you can decompile that and you can figure out everything about it. I know because we just did it, right? So this is the main thing about security. You've got to secure these things and that costs money as well. Certifications. This is like low on the totem pole of people, but when you talk about doing things for the Indian, you know, globally for India, what certifications are you going to? Are you going to have a BIS certification for all of this stuff? Are you going to have a equivalent FCC ID so that things are interoperable, or interoperable in the sense, or not affecting something? So you could have a sensor from one company that's working on a certain RF frequency interfere with another company's sensor easily. In the United States, there's a lot of problems with garage doors opening because neighbor's garage pressed the garage door open, the other garage door would open, right? So that's because a lot of these aren't certified. Now, you have certification organizations like Wi-Fi. You can say Wi-Fi certified. You can say Zigbee certified. You can say Z-Wave certified. It doesn't guarantee that everything is interoperable, but it's a step towards it. Then stacks. So how does that all together? So when I talk about stack, the Wi-Fi has a certain footprint for your chipsets, and that will take up memory and increase costs. 6LoWPAN has a very small stack, and so you can use a very 8-bit microcontroller to do a sensor. So the stack actually transcends just the sensors, but it's also available in gateways and in other things like that. So when you look at all these 7 points put together, this is going to define how your system operates, how your system is going to work, and how it's going to work seamlessly. So let's take a look at a few of the parameters that we saw before. I'm not going to go through each and every one of them, but I wanted to highlight where some of these things are. So, you know, if you look at the amount of data and embedded devices that are in the entire space, you know, I've put about every possible vertical industry segment that's available here. You know, from smart meters to pipeline management to agriculture, smart city is just, it's lumped into one huge, one bubble doesn't really justify smart city, but it's there. Street lighting, tracking, and we're here for home automation, home security, and then building automation is kind of related to both these in the red, and so is smart metering and wearables as well. But you see that for each one of these, the speed that's required is, for a smart meter, you need bits per second. For wearables, you need kilobits, or thousands of hundreds of kilobits per second, right? So, and then on this, you also need real-time communication for some of these things. And here, you can have batch communication, meaning that you can aggregate data and then shoot it across at one point in time. So where do all those different standards look at? So here, this is very loose. I don't, you know, someone will come, well, but, you know, no. It's just an example to show that, for example, you can look at Zigbee. Zigbee comes through at the low speed, the mid speed, and the high speed, right? And they're basically, but if you use this metric and say Zigbee is the best, no, that's not right. Because you have the other 6 key parameters to take a look at as well. LTE-M also can basically work on the high speed, low speed. Actually, in fact, a lot of them can. And so, Wi-Fi is there everywhere. G3 PLC actually does have limitations. So does LoRa. 6-LoWPAN has limitations. It goes to a medium speed. But you get the idea. This is just a general thing. You've got to know which technology is used for what particular speed application. So let's take a look at range. This is one of the parameters, right? And then let's take a look at the technology here. So you can see that with LTE-M, NB-IoT, and LoRa, you can get, this is in kilometers, by the way. You can, or not, sorry, meters. This is about 10 kilometers you can get easily with these types of technologies, right? 6-LoWPAN, you can get about 1 kilometer. G3 PLC, if there's no Chinese power supply on your power supply, you can get this. But some uncertified power supply inject noise into the system, so it decreases your overall range. And so, range is a very subjective type of thing because I can make the range of any sensor bigger or smaller depending on what you tell. If you tell me I've got $100 to make a Bluetooth sensor go 100 or 10 kilometers, I can do it. But it'll be very directional. I'll put an antenna. But if you say that, I have $5 to put this Bluetooth sensor, I can't do it. So this price plays into all of this stuff, but you get a relative idea of where the max limitation is on each one of these. Zigbee, a few hundred meters. 6-LoWPAN can extend it. The meshing capabilities of these extend it a bit further. Wi-Fi is, again, in the 200, 300, 400 range. So this is just an idea of what these particular technologies offer. Then, in terms of power consumption and in terms of price. So I kind of put it out into, low and high and versus power consumption is there. So all of these are basically radios that can possibly, when they're transmitting, generate up to 1 to 2 watts of power. And G3 PLC is always plugged into a main supply. So, it can use upwards of 5 watts if it needed to, because I've seen that happen in various cases. Wi-Fi, again, depending on how you do things, Wi-Fi can be a big power hog as well. But you have Wi-Fi that also can be a very low power Wi-Fi as well. And then in terms of cost or price, Wi-Fi is down there, and that's primarily because of one company in China. And probably all of you have heard of it, Espressif, which makes the ESP chips that are the small little modules. Now a Bluetooth Wi-Fi combination can be had for sub $2 in volume, right? Then you have 6-LoWPAN, Zigbee, Z-Wave. These are all power consumption-wise. There's, pluses and minuses. You can do microamps to milliamps on these, but they're there. And the cost is, I tried to give an indication of LoRa being the higher cost, Z-Wave being below that, Zigbee even lower, and 6-LoWPAN the lowest. So, but again, it depends on the type of chipset you use. NXP may give you a chipset that offers you a low price, like $1.60 for a Zigbee chip. Scilabs may give you a chip that's $2.65. But for the NXP, you have to add an external power amplifier. So there's all sorts of things that are there that basically make up into this price category. But these are just rules of thumb that you should take a look at when you're looking at technology. And these are some of the things that you need to keep in mind. This, you can see that all these technologies right now are in their own little bubbles. What if you could put them all together? And then you have a platform to put them all together so they're all seamlessly working together. This is what we need. We need basically a heterogeneous system, right? So you have Wi-Fi, Zigbee, Bluetooth, all of the particular parameters and other sensors all working together, combining together to work together. In this particular application, we've used Nebula as a framework to help that communication happen. So with brains come automation, right? Now, climate control, lighting control, you can see all of this out there. There are so many good booths that have all of these things here. Audio, visual, security, leak detection, so not just water, but gas leak detections and things like this. Then consumption statistics. So if you want, what are you doing? And then linking that back and making use of if this, then that, taking that data and making it such a interesting type of use cases. There's so many use cases. Once you have data, once you have AI, you can do about anything with that data and then start controlling things in any which way you want to. So, as one of the things that I like to say is, what is this system going to do? So it has to have flexibility, right? Let me just get my notes on that because there is a key point that I did want to make on this. So the overall system should have, you can mix and match sensors, right? So you can take sensors, during the panel discussion said there's Zigbee and Z-Wave, and how do you put them all together? Well, you have to have a system that can do it and the hardware that supports it. Cost control. By mixing and matching and using different technologies, you can use a low-cost sensor, a $7 sensor to achieve something that a $150 sensor could achieve the same way. You can have decision speed. So with all that data analytics, data points that you can analyze, you can make and refine decisions that are there. And then basically with decision speed if this, then that could go on to steroids, essentially. You can do many, many new things with it. And then there's relevance. So relevance, by saying some technologies and protocols, they will die a slow death sometimes. So for example, Google announced maybe 5 years back Thread. Where is Thread? Nowhere to be seen. Or it's now been subsumed by another protocol or within this ecosystem. And then you have Zigbee. Zigbee may upstage Z-Wave at some point in time, right? Because like IKEA just announced that they joined the Zigbee Alliance board. Now they're there to basically promote Zigbee types of sensors. So what happens to Z-Wave then? So I don't know, how many of you remember VHS cassettes? Maybe I'm too old. But there's VHS versus Betamax, right? It was a pure marketing game. RCA marketed VHS as the best thing and then pushed it and pushed it and pushed it. And therefore VHS became the worldwide global standard, right? Same thing with Zigbee. Zigbee has millions of dollars behind that particular technology and lots of branding behind it. So therefore, people are going to join it, and then that can become the leader. So anyways, my point is that the system then basically has to have relevance, especially when there's a major brand pushing that technology. So in a nutshell, the long story short is that, and now I've introduced something new, but my talk is only 15 minutes. I can talk another 3 hours for some of this stuff. But you have all these nodes and sensors and stuff like that. You want to push them to the cloud. You need some sort of gateway in between, and then basically your end users, so your end user applications can be used through the cloud or through the sensors combined. And you have to have some brains in the middle here that collects this data. And the way to achieve that is to basically trying to use a mixed system of technologies and having an ecosystem that supports that mixed system. Thank you very much. I think I have 27 seconds left. I don't know if there's any time for questions. But yeah, any questions for me? Yes. So there are a number of ways to make this network secure. That is at the device level, what you saw, that you have, you can basically put AES 128 and make use of, let's say, ARM's security systems within the device. Then as you go forward, you can use TLS and you can use other types of net technology to basically make the transaction secure, and you can use like encryption technology as well. Same thing as it moves forward to the cloud. And in the cloud as well, you've got even more basically security that you can use. So it's a multi-tiered security architecture that's there for this. And so, as I told you, one example was Nebula. We've built Nebula for that, and so it's built for doing this type of stuff. Yeah?
Any other question? We can take a one or two more. So audience members, feel free. Yep.
Hello, I'm Praneeth and I work for a company called Innobox, mostly into routers and networking equipment. So my question to you is, you mentioned a lot about the 6 technology being used in the market. So can you state some of the deployments in the real field in India?
So in India right now, so I'm a part of the Bureau of Indian Standards Gateway initiative. And right now, security and the protocols are being hotly discussed. And routers and gateways will be a part of that. So that, like I said, the security has to have an end-to-end security layer. And so then this basically, you have to use the best in breed from a number of various technologies. Like for example, you can make use of ARM trust zone at the device level and also at the gateway level. Then you can use TLS or PKI or public-private key encryption that takes it to the rest of the system. And then when you talk about security as well, is that just the fact that security has to come from within the organization, so people security, so passwords and where the servers are, all the data center security needs to be involved. So it's basically, it's a whole ecosystem that has to implement the security. And India, it's in its infancy right now for implementing that stuff, because right now you don't see a whole confluence of data centers here in India that you have full access to, and people are still trying to understand, everybody uses Arduino. Well, Arduino, and they don't know how to basically use all the underlying framework for Arduino for security and stuff like this. As people start getting their knowledge base up on this, they'll start using Trust Zone, they'll start using other technologies that are in there from the device level itself.
We'll take one last question. One last. So you choose your pick, sir.
I think yeah, wait.
Hi, I'm Rohin. Any thoughts on Bluetooth mesh as an interoperable standard for smart buildings?
So look, Bluetooth has its advantages, right? Bluetooth, I can take my cell phone and I can, if another device has Bluetooth, I can walk up to it and I can connect and I'm immediately controlling, right? That's the beauty of Bluetooth. If I use, for example, Wi-Fi, well, now which do I put Wi-Fi in AP mode? Do I put it in network mode? How do I get into the network mode seamlessly? That all is a big challenge. So Bluetooth has its advantages, and it's the use case that's really there for it. And now with the latest, greatest Bluetooth and the meshing capabilities, you are not limited to just 8 devices. You can actually expand it out more than that. But Bluetooth has its niche as well as other places. So it's all about application. And sometimes people want to cross the applications across as well.
So because I'm a very, very kind individual, I'll have you take the last question because we wouldn't want the audience members feeling bad. Last question for the day, sir.
Last question.
Today's your lucky day. Yeah. Yes.
I'm Ajay Lade from Adani Electricity. You mentioned various communication technologies like Bluetooth, Zigbee, Z-Wave, then Wi-Fi. So for typical setup of say 1 BHK or 2 BHK, say 800 square feet, 2000 square feet flat. So according to you, which is the best technology, Wi-Fi or RF or something else?
So look, it depends on what you want to use. Wi-Fi is great for when you want to have, let's say, a smart switch, or you want to have controllers inside your panel. Wi-Fi is great because you always got power there, right? Now, you can't use Wi-Fi everywhere, right? If you have a small temperature sensor that's sitting, that you want to sit in your kitchen, for example, Wi-Fi is going to take up too much power and your battery is going to drain, okay? So then what you have to do is use a different technology. You can use Z-Wave, you can use Zigbee, but then your gateway has to support, if you want a unified mechanism, one way is your gateway does the unification, or both, let's say you have 2 gateways, one for the Wi-Fi, one for Zigbee. Both those then go to the cloud, and the unification happens at the cloud level, right? So, again, for a 2 BHK home, yes, one would argue that you could cover the entire home with Zigbee sensors, but then a lot of Zigbee sensors are expensive, right? I can go to China and get a little Wi-Fi based sensor that's $6. The same sensor for Zigbee may be $12. So, the whole thing is, like I said, the key price, range, and application, and battery consumption and power, right? Those are the things. So that's why I'm saying is that, let's talk about mixed use case networks rather than just one particular pigeonhole.
Sir, my take from your entire speech, which you'd given out, considering your awe for the Chinese, considering you mentioned it thrice, it seems to be a very big awe for them. And it just, reinforces the stereotype, sir. Sir, are you aware of the stereotype?
Yes, I am.
The stereotype is, no matter how talented you are, there's always the Chinese kid better than you. All right, thank
Not true, though.
you. Is it? The Indians?
No.
The Indian kid?
Yes, I think India has a great opportunity. What we're missing is just some of the ecosystem stuff for manufacturing and testing. It'll get there. It's getting there. I think the new initiatives of the government are helping, and we ourselves need to start looking at thinking that we should actually buy Indian, show some nationalistic tendencies, not just try and get the lowest cost solution from a foreign land, right? And we also have to help our own, so that way it'll help our own companies here grow. So when we grow from within, it's going to be much better.
Absolutely.
Thank you,
I
Nikita.
truly agree. Thank you so much. A round of applause for Mr. Paresh. That was a very, very interesting session. I request Mr. Sandeep Singh to kindly come on stage and present Mr. Paresh a token of our appreciation.